This Buick features the 3.9 liter V6. So we will have 6 fuel injectors, 2 banks of 3. As you can see here, they live underneath the intake manifold. This right here is our cylinder 2. It's bank 1, bank 2, 135, 246, and they hide under there. See, that wiring had some repairs, but this is the one we're going to be focusing on, which should be a black with light green and a pink wire. Another point of note on this vehicle is that we have 2 fuses for our fuel injection system. Fuses 2 and 3. Fuse 2 controls the odd fuel injectors and fuse 3 controls the even fuel injectors. And they are these 2 fuses right there. Okay, so making our way to the trunk of this Buick, we have conveniently placed our all data, because back here, if you pull up the trunk lid, or not the trunk lid, the trunk carpeting, see right there is our fuel pump access cover. Normally this would be screwed down, but since this is a lab vehicle, it has been removed for the purposes of looking at things. And if you see on our wiring diagram right here, there's our fuel pump and sender assembly. So the gray wire is our power off of our fuel pump relay through the fuse. And then our black wire is our ground. It goes to G403. So coming back in here, we have our fuel pump assembly right here. Apologizing that the lighting's a little bad. We have our fuel tank pressure sender right here. So this is similar to like a map sensor, except it senses tank pressure. Our fuel line, as you can see, we only have one line coming off of it. And then this right here is the power for our sender assembly and our pump. You see right there, we have a gray wire on the far right and a black wire on the far left, noting that those 2 for the power and ground for the pump are a tiny bit thicker than the other 2 for the sender assembly. All right, right now we're just gonna show you a basic power at test for our fuel pump. You can see I am probed into the gray wire, which is the power coming in for the fuel pump, and we're connected to ground on the back of the shock tower back there. So if Karen, you want to go key on real quick, you can say you can hear the fuel pump prime, and we have just over 11.5 volts on that wire. So we do have power back here. That's just a quick test you can do at home to make sure that your fuel pump is getting power. Okay, so taking a look at our diagram here, as you can see, each fuel injector has a pink with black wire. This comes from either that even fuse or the odd fuse, which in this case would be coming from even since we're on 2. And our light green with black, or different color wires, are our PCM control over the fuel injector. So right now we are probed into what should be light green with black. However, as you can see, it's not, because we have a different connector in there that has been replaced. The vehicle is currently running at idle, and as you can see, we have a really nice waveform of that fuel injector. You can see there, if I change the time frame here down, we can take a closer look at what that signal looks like. You can see right here it opens, it stays on, and then it closes, voltage spikes, and then it carries on. But if I have Karen put some RPM in it, we can watch as it increases and these get closer together. So Karen, if you want to accelerate, and as you can see, our waveforms get closer and closer together as that fuel injector fires more often. Okay, you can let off, and you can see as we let off, they separate. Okay, as you can see, we are still probed into the number 2 fuel injector on the vehicle with it running at idle. And at idle, I'm using this ruler to show about how long that fuel injector is on for. So if we look, it's about 2.3 milliseconds between the time it turns on and then finally shuts off. So, and as we need more or less fuel, as the PCM deems, it'll kind of fluctuate, but it tends to stay right around 2.3 to 2.4 milliseconds. Okay, so right now we're sitting back inside the Buick, looking at some of our live data. As you can see, some of these are related to fuel. We have our injector pulse width, which as you can see right now is hanging right around 2. So pretty similar to where we saw it before. If I give it a little throttle, you can see it increases. You see our short-term and long-term fuel trims, as well as these 2 PIDs right here, power enrichment and deceleration fuel cutoff. Now, unfortunately, right now, I can't demonstrate decel fuel cut, which what that'll do is if you're at a higher RPM or driving and quickly let off the throttle, it'll shut fuel off in order to help bring the engine RPM down quickly. Now, power enrichment, however, is a mode that the PCM uses when you jab the throttle, and it'll add more fuel before it recognizes that there's more air in to prevent a hesitation or stumble on acceleration. So if you watch as I step on the throttle really quickly, we go into active power enrichment mode, where it really quickly increases fuel flow into the motor. Here's another quick showing of some more data. This going back kind of to last week's video on air fuel sensors. As you can see, we have closed loop and power enrichment shown. And power enrichment is really only enabled when our loop status returns back to open. So if I step on the throttle, you can see we go into open loop and power enrichment. And as soon as I let off, we go back to closed loop and it deactivates our power enrichment mode. That's just some interesting information for you guys.
Right now, I am connected to the ground side to an injector. I am back probed into the brown and the yellow wire, as you can tell there. I am connected to positive, and right now we are reading the voltage drop of that injector. We are reading about in between 0.09, 0.36 volts DC, around there. Right now we are still connected onto the positive and then onto the negative side of the injector. We're gonna be testing for how much of a voltage drop there would be on this vehicle if we were to put propane in through some type of air filter or throttle body. We're testing that right now. You can hear the car slowly kind of want to just not run anymore. This is because there's too much air, too much propane going into the system. Right now we are still connected to the circuit of the injector on the ground side. You can still see the voltage drop, but right now we're going to test to see if the vehicle will die if there's too much propane done and put into the system. You can hear the rough idle. Takes a little bit of time, but eventually with too much propane in the system, the car will cease to run.